The next section we're going to take a look at is called pinning charts, and pinning charts are really nothing other than just a couple of rows of numbers that, or maybe more than two rows of numbers, it could be three or four, that just simply help you when you're doing the physical combinating of the cylinders. And I've thrown this very short chapter into this primer just because you may have heard the term pinning charts. And unless you're going to be doing the actual pinning yourself, or unless you're already just simply familiar with the concept of a pinning chart, this section may not have much appeal to you, but let's talk about it. An understanding of locksmithing, master keying, and the science of cylinders is better understood when you can grasp how to load pins in a cylinder plug. More specifically, what pins do you use and in what sequence do you load these pins? And if you were to enter into a fundamental locksmithing class, they're going to spend a lot of time on talking about how you select which pin will go into the cylinder plug. And just simply, and to me and to other people, it's quite second nature, so it's difficult to explain it effectively when it appears to be so obvious. But I can assure you, if it's not obvious to you, it was at one point very not obvious to me, that's to be sure. The bottom line is you do need to load the pin in the chamber that will be the smallest bottom pin. So if you have a 2 cut on your change key and an 8 cut on your master key, you're definitely going to load the smallest cut, assuming that 2 is smaller than 8. You can be in a system like ASA where that's not the case, where the bigger numbers are the shorter pins, but you would load or dump or place that smallest pin regardless of what key it is. It can be a change, it can be a master, it can be a TMK, but whatever is the smallest cut is what you're going to load in there. And a pinning chart basically just shows you the pins that you load. Doesn't show you the cuts on the key. It's somewhere within the pinning chart. You just don't know, if all you see is a pinning chart, you don't know what key is what key. But it's just something that you can look at so that when you sit down to do the physical combinating of the cylinders, you're not thinking it in your head. You're just ritualizing the process so that if you're going to key a bunch of cylinders, you may create your pinning chart. When we do interchangeable core, we absolutely create pinning charts first. And I'll show you a small format interchangeable core, I should say. Small format. If it's large format, we probably aren't, but pinning charts are a part of the paperwork or a part of the process. So you're going to load the smallest, shallowest cut into the chamber first, and you will stack on top of that master pins, or build-up pins, or driver pins, or whatever it might be. Every system that you're going to work with has a specific set of rules that governs how cylinders are pinned, or combinated, which is the industry term for the act of physically loading the pins into the chamber. So if you're going to combinate a cylinder, you're going to take pins out of your pin kit and you're going to actually put them in there. That's combinating. The term combinated can also refer to a cylinder. Are you ordering it combinated? Do you want there to be pins and drivers and springs and a spring cover or in operating keys? Do you want all that work done, or do you want to order uncombinated cylinders? Very typical for small format work, where you're just going to order the blank uncombinated cores themselves, and you're going to do all the pinning. And someone like Falcon will have different part numbers for combinated versus uncombinated. So it can also be used in that regard as well. Schlage, Kwikset, Corbin, Russwin, Medico, Sargent, ASA, and all others, and the rules surrounding their systems dictate how you combinate your cores. You'll have to just dive into each system. And if you're most familiar with just pedestrian pin tumbler, Kwikset, Schlage, Arrow, things of that nature, all those rules are the same. If you need to dive into interchangeable core, whether it be by Sargent or Yale, Corbin, any of the exotics. When I mean exotic, I mean like ASA, stuff that you won't bump into as much. At least I don't. Or if you're going to key something like Medico, which absolutely requires advanced training to even approach that, because their pins have different sizes, but they have 4 center and aft cuts, and then they can take those pins. Well, it can be aft, 4 and aft cuts is what it is. But then, so you can take the pin and you can have an odd chisel point on it, and then you can also take those pins and skew them left, right, and center. So if you're going to dive into Medico, you're certainly going to need to study that. The good thing about Medico is they have information published. If you're a member of ALOA, and I don't think it's necessary, but if you're a member of ALOA, you get access to the people and those training classes that will allow you to do it. A lot of people that I've sat in classes with, I've heard people say, yeah, I just sat through the Medico certification class, and they're giving you the service manual and teaching you how to do it. And with Medico, you'll definitely need to do some research and homework and study before you start pinning cylinders. And if it's interchangeable core, there's some other rules that you have to know as well. There's a relationship between the change key, or any key really, well, whatever operating key it is, and the control key. There's a fixed relationship there because they don't have a second shear line for that per se. But when you lift the pins appropriate to move the control lug by having a cut specific for that in relationship to the operating keys pin that you've dropped in. So the point of the matter is pinning charts can get more exotic. And Medico is a great example of that because you've got lots of different pin choices that you can use. To serve as a brief example, there's an example of a pinning chart on the screen. And I think what we'll do now is let's switch to the screen view. Let's take a look at that pinning chart, and then I'll create a small format pinning chart for you just to see how the concept of a pinning chart gets extended to something that might be more taxing to do in your head. Meaning if you're combinating cylinders, you've got 2 keys or 3 keys that you're keying in a cylinder, maybe 4. You can have those biddings written out, and you can just quickly do that in your head. It's a little slower with small format. Also, a pinning chart with something that's more taxing like small format is that it serves to reduce the amount of errors that you'll make along the way. It's a hassle pinning small format in the sense that it just takes more time, and the last thing you want to do is combine all of it, put your drivers, your springs, individually cap, or if you're going to use a capping tool, or if you're going to have Falcon and you're going to have a spring cover and you're going to hammer that down, and all of a sudden, your control key doesn't work, and that's a hassle. So you've got to take more time doing that. Pinning charts help you do that. And you can even consider using something like Excel if you want to build quick formulas, because it's all formula based in small format, whether it be A2, A3, or A4. The system, there's a total, a pin stack total. A2 happens to be 23. It's the most common. And let's switch to the screen view now. Let's take a closer look at pinning charts without overdoing it, which I fear we've already done. So let's move on. Okay, here's our pinning chart on the screen. And to serve as a brief example, here's a pinning chart for a cylinder in a 3-level system. Okay, so here's our pinning chart. Master pins, bottom pins. The way that I write pinning charts, and other people do as well, but not everyone, I put the bottom pins on the bottom row. And I just go up from there, so to speak. I'm going to blow this up just a little bit. BP stands for bottom pin, MP stands for master pin, and the above pinning chart is the chart for these keys. Your TMK is 470529. Your master is 692529. Our AA1, or our first change key, the pinning chart for this change key is 692741. So AA1 is a change key. We know that because there are letters and numbers AA1 is going to be automatically pinned to the AA1 key, the AA key, and the A key. That's how that's read. So in order to make all three of these keys work, we're going to build a pinning chart. Well, what's the shallowest cut? Well, it's a 4. What's the next cut? It's a 6. So what do you got to add to get to 6 from 4? Yeah, it's a 2. Same logic. 7 is the shallowest, 2 to get to 9. 0 is the shallowest, 2 to get to 2. 5 is the shallowest, 2 to get to 7. 2 is the shallowest, another 2 to get to 4. 1 is the shallowest, and then an 8 to get to 9. If you load all those pins, these 6 bottom pins and these 6 master pins, I assure you that all three of these keys will work. But as I mentioned previously, and will at length in an upcoming chapter, so will an additional 61 keys, is the truth of the matter. Let's see. Yeah, so will an additional 61 keys operate that cylinder. Well, I should say there will be 64 keys total that operate that cylinder, and so 61 plus these 3, and that's just the inherent nature of total pin position progression. The above pinning chart is an example of how to construct a pinning chart. I construct pinning charts with the bottom pins at the bottom of the chart. Others do construct these charts differently, and I encourage you to build yours the most favorable way that suits your workflow. Unless you are accommodating cylinders, the above chart will serve only to connect a visual table with a term. Just if you've heard the term pinning chart, it can look like this. Let's take a closer look at what a pinning chart would look like in a small format scenario. Okay, let's build ourselves a pinning chart for small format. Okay, so small format interchangeable core is, as I had said earlier, a bit more laborious. It's not tedious, it's not harder. You've just got to do more work. So I'm going to create a master. I'm going to create a change key. I'm going to create a control. And I'm basically going to build at least part of a pinning chart and do so to demonstrate the value of a pinning chart. And small format's a great way to demonstrate that. So my master is going to be, and I'm just using very made up numbers in my head as I go along. It'll be 7 pin, let's say. Fine, there's no max. Okay, so these are 3 biddings: the master, the change key, and a control key. We're going to make all 3 of these keys work a small format core. Now the issue with small format, I've already screwed that up, is, as I said earlier, it takes more work. Small format is a bit more distinguishable because the lobes on the core are equal, whereas large format, the bottom lobe is generally larger. The issue is you're going to have a bottom pin, and you'll have a master pin, and the master and the change key need to operate at the plug shear line. Well, in small format, you have a control lug shear line. that you have to pin to, because the control lug here has to have a pin that satisfies it in order to retract the control lug so you can insert and remove the core. And that's what the job of the control key is. If you try to pin this in your head, you can do it. No doubt. It's just because small format is more laborious, and all you want to do is key these and go home, and you've got 20 to do, taking the time to build the pinning charts will get you home faster because you're ritualizing the process and you are rooting out the errors beforehand in a way that you can kind of figure out where the error is coming from, because the last thing you want to do is take the time to combinate the cylinder, add all these pins, 7 times 3. You got 21 pins in the chamber. Oh, I lied. You've got 28 pins in the entire cylinder. You've got 28 because you have driver pins. Well, yeah, you're going to have 28 because that's no good. Make that a 4. And springs, and you're going to button up that plug by either capping it or putting on your spring cover, and now one of the keys don't work. And then it's a hassle. You got to eject all the pins, so pinning charts help. Now, small format in this video, the set part of this video is not to teach you how to combinate small format. I probably have I know that I have a video going through it quickly, like how to pin small format in 60 seconds. So you can review that and other available sources online. The best service manual has all of this information. It's a bit esoteric in the sense that you kind of have to have an idea of what they're talking about. But if you study it hard enough, you'll notice that, well, that's the only way that can work. So without beleaguering those points, let's just build a pinning chart. So same logic applies. What's the shallowest cut? It happens to be a 2. We're just going to do the first chamber. Shallowest cut happens to be a 2. What's the next cut? It's a 4. So what are you going to add? You're going to add 2. Now, there are 2 rules with small format. The values of these 2 rules are dependent on whether it be A2, A3, or A4. A2 is by far the most common. We're just going to deal with A2. The magic number, there is a magic number. The 2 that we're going to touch on are 10 and 23. So the first thing you have to do after you establish what pins you're going to load to satisfy your operating keys is to make the control key work. Here's rule 1. Take the control key, add 10 to it. So 2 plus 10 equals 12. You subtract from that what you've already loaded. What's the value of what's already loaded? It's 4. Or you can just take the deepest operating cut, subtract 4, that equals 8. 8 is your driver pin. We've got a bottom pin, a master pin, and now a driver pin. Here's rule number 2. So that's this number 10 rule. The 23 rule is this. The total of the pins in the chamber must equal 23. So therefore, 23 minus 12, 8 plus 2 plus 2, equals 11. Your top pin must be 11. So we just did a lot of work to build a pinning chart of 1 chamber only just to make 3 keys work a cylinder. Let's do the next one. The next one's going to be a 1 and a 6. Add 10 to the control. That's 14 minus 7 is 7. My control pin is 7. I'm saying build-up pin or control pin. Those terms are somewhat interchangeable. Control pin might apply more because it's going to the control lug. So we don't need to make a 4 operate down at the operating shear line. So that 4 has to operate at the control lug shear line. So we got a 1 bottom pin, then we need a 6 master. We add 10 to the control. 10 plus 4 is 14, minus what we've already loaded, which is 7. 14 minus 7 is 7. 23 minus 14, 7 plus 6 plus 1, 23 minus 14 is 9, right? Yeah. So your driver pin is 9. Let's do the next one. Our shallowest cut is a 2. We need a 3 to get to the 5. Add 10 to the control cut, which is 15 minus 5 is 10. 23 minus 15 is 8. Let's just do them all. 6, 2, 11 minus 8 is 3. 23 minus 11 is 12. 3 and 7, so 3, 4. 10 plus 3 is 13, minus 7 is 6. 23 minus 13 is 10. We're going here now. 5, 4. 9 plus 10 is 19, minus 9 is 10. 23 minus 19 is 4. We're doing the last chamber. 1, 3, 7, 11. 1 plus 10 is 11. Minus 4 is 7. 23 minus 11 is 12. That's our pinning chart. Those are all the pins that you're going to have to load. Now that took a long time, but to do all that in your head as you're loading pins, again, ritualizes the behavior and lessens the potential for error. So a pinning chart can be super easy, like the one that we showed on screen earlier, or it can be something that's a far more important tool to actually use when you're combinating cylinders. And again, small format is a great way to illustrate that. I hope I didn't make any mistakes while I was doing that. If I did, point them out to me and I will review, acknowledge, and apologize. But nonetheless, the logic is I'm just trying to get across the point that sometimes combinating can be a hassle. If you dive into ASA, and I do have an ASA manual on my website, you're going to need a pen and paper, in my opinion, to combinate that stuff, because there's just a lot of rules to come up with when you're dealing with ASA, and most definitely their interchangeable core. All right, let's wrap up this video. So that is the short chapter on pinning charts. May or may not apply, but nonetheless, it's helpful information to be aware of. The next is expansion specification, and that is really where the rubber meets the road when it comes to being able to talk to your client, listen to what the client says, putting it into a construct that construct you can then temper against, is it possible? So let me say that less obtusely. Your customer says, this is what I want. You're going to be able to put it into the expansion specification format, and that will tell you, can I do it? And it's extremely helpful to learn the expansion specification. And I'm sure I'm going to mention it countless times, but Jerome Andrews' book, Fundamentals of Master Keying, goes into it very exquisitely. So let's dive into it.